Algebra I Honors, Lesson 4.7, Arithmetic Sequences, and Lesson 4.8, Writing Equations from Patterns. So, arithmetic sequence, it's a set of numbers, a certain order, and it goes up by a certain amount. So 3, and it's listed as commas, 6, 9, 12, dot, dot, dot. In an arithmetic sequence, and I don't know if they'll get into it here, the value that it goes up by is called the D value. It's called the common difference. Let's see if we get into that. Yeah, we do. Very nice. So we call this 3, which is the common difference. Could be negative. Doesn't have to go up. Could be ugly. Could be a fraction. How do we find it? We take any term, we subtract the previous term. 2 minus 1 equals 1. 4 minus 2 equals 2. This is not arithmetic, because it has to be the same each time. So this one is 1/4 minus 1/2 is negative 1/4, negative 1/4, negative 1/4. So this is arithmetic. And it's D equals negative 1/4. So now I'm telling you it's arithmetic. You know it's arithmetic. You don't have to check. Say it's going down by 7. I can tell right here. D equals negative 7. Find the next 3 terms. Well, just subtract 7. 46, 39, 32, 25, and then check it. Plus 7, plus 7, plus 7. Yeah, it looks good. So that's an arithmetic sequence. So here's a formula, and it's very, very similar to a linear equation. Any term, a sub n, and we say it like that, a sub n, meaning the n is written below it to the right. This is wrong. Doesn't mean anything. Equals a sub 1, the first term, plus common difference you know, and n number of terms. I want the 14th term, n equals 14. So I want the 14th term, n equals 14. Find the 14th term of this sequence. What's it going up by? Looks like D equals 8 and A1 equals 9. So any term, in this case the 14th term, is 9 plus 8 times 14 minus 1. 9 plus 8 times 13. No way I'm doing that in my head. Wish I could. I could, but I'm not in the mood. Plus 9 equals 113. So this is a linear function. All functions are linear, so it's a linear expression. So you look at this, 12, 23, 34, 45. Now, I like to do this. I haven't done it so far. This is term 1. This is term 2. This is term 3. This is term 4. Write an equation for the nth term of the sequence. A sub n equals first term, 12, plus what's going up by? 12, 23, 34, 11. That's the D equals 11, times n minus 1. You say, well, what n are we using? Read the question. The question says, write an equation for the nth term, so I just did. Find the 10th term, so what's a sub 10? 12 plus 11 times 10 minus 1 equals 99 plus 12, which is 100 plus 11, 111. And graph the first 5 terms. So this is how I had to set it up to graph it. I have to know what the terms are. Term 1 is 12, which I'm going to put right here. We're going to go up by tens. Term 2 is 23, about there. Term 3 is 34, about there. Term 4 is 45, about there. Term 0 would be a little bit bigger than that, so again, we put a line through everything. Should I? No, this is a discrete. But I like putting a line through things, so I did it. If you didn't put a line through, I can't really argue. 1, 2, 3, 4. I really should have done one more. Yeah, whatever. It's up here somewhere. So that's it. That's arithmetic sequences. They can get wildly complicated really fast, but it's just a linear equation. It's an example of a linear process, and these pop up everywhere in the world. You'd be extremely surprised. Now we throw something else at you, which feels kind of out of left field. Write an equation given a pattern. So look at this pattern. Top left, top right, bottom left. Top left, top right, bottom right, bottom left. Draw the 27th circle. Aha! Now you're making us think a little bit. We'll notice every fourth one repeats. So 4 is the same, 8 is the same. Hey, this looks like an arithmetic sequence. 4, 8, 12, 16. Did I really have to write all these out? You know what? I'm a cautious guy. 28. 127, go back one. So take pride in my circles. You should too. Jeez, please. Go back one. We're down in the right quadrant. Want to count them all out? Go right ahead. I would actually do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 5, 26, 27. Looks good to me. So you're just making patterns. This table shows the average amount of gas. Rogelino, I don't know who that is. Love to make fun of somebody in my notes, but this one isn't mine. So his car uses depending on how many miles he drives. Graph the data. 140, we're going to have to go with 20s. 20, 40, 80, 120, 160. Should do it for now. And of course the other side is just ones. 1, he gets 28. I don't know what he's driving. I don't get that kind of mileage. 2, he gets 56. 3, he gets 84. 4, he gets 112. Gotta be careful on that one. 4, he gets 112. Yeah, right about there. 5, he gets 140. Now, I can put a line through that. It's continuous. Gasoline is, molecules are burning basically. But I can just say this is a linear relationship. Nothing earth-shattering there. Write an equation to describe this relationship. Well, if he hasn't driven anywhere, he's got 0 miles. Maybe I could do that a sub n thing. How much does it go up by each time? Well, that's tough. Here it goes up by 28. Here it goes up by 828. Here it goes up by 828. Cool. Here it goes up by 28. Very interesting. So the first one is 28. So yeah, I get this whole mileage equals his first mileage, 28, or miles I should say, plus some n minus 1 thing here. And we said it went up by 28. Cool. Now that's one way. The way we typically see it is more like this. 28 plus 28n minus 28. These two cancel, so it would say the miles driven is 28 times gallons of gasoline. So I'll change that N to G. Cool. Linear. Off the top of our head, why don't you go find the next 3 terms for each one of these. And here we go. Hey, this one isn't linear. Can't do it. Not linear. That's not what we said. We said go find the next 3 terms. I don't recognize a pattern here. It doesn't seem to make any sense at all. Let me think about it. Hey, you know what? Those are all perfect squares. I bet the next one's 25, 36, and 49. These aren't linear, but I can figure them out. Interesting. 9, 7, 10, 8, 11, 9. What? What? Seems weird. What's going on? Let me skip and see what's going on. 10, 11, 12. Let me see what's going on here. 7, 8, 9. Oh, so the next one is 10. 7, 8, 9, 10, 11, 12. And then for this one, we get 9, 10, 11, 12, 13, 14. Oh, yeah, I see the pattern. Actually found the next 5 terms. Only needed 10, 13, 11. So it's, it's a little test. See if you're smart enough to figure things out. It's not easy. But this is the point where we start pushing you a little bit. You're 4 units in. You've got 14 units, I think, to do. You need to start showing that you've got some math ability. And this is a good time to do it. So good luck. And once again, happy mathing.